Right, hello everybody. Today I'll be going through more on the TMA, which is the Thermomechanical Analyzer. Right, before we begin, I would just like to go through the fundamental principles of the analyzer, which basically just utilizes the relationship between stress and temperature. And for further clarification, it is a deformation of the sample under non-oscillating stress, which is monitored against time or temperature, while the temperature of the sample in a specified atmosphere is programmed. So essentially what this means is just that any random variables from this test is being eliminated such that the results of the sorry such that the results of this analysis is accurate and only dependent on stress and temperature. Any types of stress generated can include expansion, compression, tension, or degree of bending. These analyzers are useful for mechanical analysis of materials such as glasses, polymers, metals, and ceramics. So over here we have a schematic diagram of the TMA. The key components of this of the TMA include the furnace, which provides the independent variable, and the force generator, which provides the dependent variable for the analysis, and also the LVDT detector, which provides a signal whenever there is a displacement in the sample, and also the probe in order that generates a different kind of force, which generates a different kind of force depending on the probe. Right. So the steps would firstly to be inserting the sample into the furnace and being heated, and after which the sample will come in contact with the probe, which is connected to a length generator and a force generator. The force generator would then apply a programmed force to the sample via the probe, and as the sample softens when it's heated up, in addition to the force that is being generated, it would cause the sample to expand, and this expansion will be classified as sample deformation and thus measured by the length detector. The length detector that is being used here is the linear variable differential transformer, also known as the LVDT. Right, so the types of probes that can be used are expansion probe, penetration probe, tension probe, and deflection probe. So essentially what these probes do is that they generate a different kind of force depending on the probe, and the types of force, as we learned in another module known as the mechanics of materials, for example, the flexure probe generates a bending force at these points as my cursor is pointing, and the expansion probe obviously generates an expansion force, and etc. So the expansion and compression probe, it measures deformation by thermal expansion and transition of sample under applied force. So essentially it measures something called CTE and TG, both of which I will discuss later on. Next will be penetration, which is used in the measurement of softening temperature. Before I elaborate any further, I'd like everyone to take note that there's a difference between softening temperature and glass transition temperature. Next is tension, which measures thermal expansion and shrinkage of the sample, and is especially useful for measuring films and fibers. Lastly, the flexure probe, whereby the sample is bent in 3 different locations, which I mentioned earlier, and is used to test tensile strength and modulus, and can also test softening point depending on the sample that's being used. Right. So for the LVDT, it's essentially just a hollow metallic cylinder with another shaft that can move freely between the cylinder. And how it works is that initially the shaft would maintain right in the middle of the primary winding, and it will be spread slightly towards the secondary windings. But essentially, the primary winding will be connected to an AC circuit, and as a result, this would induce a electromagnetic field around the core. And as the force is applied, the sample will be placed. As the force is being applied, the sample will be displaced in the direction of the force, and this will move the coil in the direction of either of the secondary windings. And by moving the coil, there will be a fluctuation in the strength of the magnetic field, and therefore resulting in a fluctuation in the magnetic current that's being generated. And this would provide a different signal, and this will be converted by a machine into a different signal output.